Our research is entitled The Comparative Analysis of Biogas Production from Various Ratios of Cow Manure and Pig Manure. We are the researchers, Aksa Halandoni, John Roderick Madeja, and Pope John Pial. Let's start our journey by explaining what biogas really is.
Background of the study. Our study aims to produce biogas using various ratios of pig to cow manure. Along with food waste biomass, this research is essential for understanding sustainable energy production methods.
Next is statement of the problem. It demonstrates differences in gas weight, methane content, and manure ratios in a digester. Specific experiments are required. This addresses the need for reliable data in optimizing biogas production.
So, for our objectives, include the evaluation of gas weight, methane content, and combustibility in biogas production. By achieving these goals, we aim to contribute to the development of the efficient of biogas system.
We will follow the conceptual framework, IPO, input, process, and output. For input, we have our manures, food waste, and biomass. The process are the steps that we will follow to ensure a more precise and stable outcome. And on the output is where we conclude our study.
For research materials, we utilize common materials such as water bottles, balloons, drill, and gas bulb, along with cow and pig manure. These materials were chosen for their accessibility and suitability for our experiments. For additional materials, included super glue, gas indicator, and 2-liter bottles for our experiments. Each materials played a specific role in the setup and execution of our biogas production trials.
It is important that we ensure the airtightness of each of our digesters. We use drill to make a hole precisely so that our tube will fit. After that, we have glue and electrical tape that ensures the airtightness of each digesters. Then we use balloon as a containment of our biogas. It is important that we use precise measuring tools, as methane content is hard to measure on its state, so we use this apparatus. This is the methane content indicator. It has a very sensitive methane detection and can be used to precisely measure the methane content. In this picture, we fermented the manures in separate containers. We add water for a manageable liquid that we can use. And while waiting, we construct our digesters. It is seen below. We are careful and we avoid mistakes, so it is shown that we have 5 digesters in case of emergency. In this picture, we measure and labeled each digesters. For digester 1, we have 75% cow, 25% pig. Digester 2, 75% pig, 25% cow. And for our control, which will be our digester 3, have 50% pig and 50% cow.
Research procedure. Our procedure involved making digesters, collecting feedstock, fermenting manures, and assessing gas weight, combustibility, and methane content. This comprehensive approach ensures accurate data collection and analysis.
Here is our statistical treatment. We use one-way ANOVA to evaluate the difference of each 3 digesters. It is important to precisely get the results, especially in our scientific research. It helps us disseminate what are the differences and what each ratios output in terms of biogas production. Here on our results and discussion, the alpha level is set at 0.05, and it is evident that our p-value is less than the alpha level. Therefore, we reject the null and accept the alternative hypothesis. In that simple statistical treatment, we notice a huge difference in terms of gas weight. Here's our digesters ratios. For digester 1, we have 75% cow and 25% pig. For digester 2, we have 75% pig and 25% cow. And for our control, which is digester 3, we have 50% cow and 50% pig.
Findings: the optimal ratio for biogas production was found to be 75% cow to 25% pig manure. Combustibility and methane content varied among the digesters. These findings have practical implications for biogas system design and operation.
which consists of 75% cow and 25% pig. We recommend to get the cow manure fresh from the farm because cow manure is the kickstarter of the anaerobic digestion which break down any biomass which then produce the biogas that we researchers need. In conclusion, our study demonstrates the importance of manure ratios in biogas production, with significant differences observed in gas weight, methane content, and combustibility among the tested digesters. These findings contribute to the ongoing efforts to develop efficient and sustainable energy solutions. In biogas research, we optimize anaerobic digestion of organic waste for methane production. We experimented with gas weight, combustibility, and manure ratios to enhance efficiency. Collaborating with peers, we developed novel techniques for maximizing biogas yield. Here is our little picture, where we ensure that each digester has equal gas leak measures. We are creating an airtight valve for biogas to pass through and be collected at the balloon. It is sure hard to keep up with the standard, but it is needed for a more stable outcome.